Okay, so the second half of 9.8 doesn't just talk about the radius of convergence, it talks about an interval of convergence. Now, on a number line, if you have a radius of convergence of 1, it goes out from the center 1 on either side. So it's easy to generate the interval. The hard part is, at the very ends of those intervals, the endpoints, are they included or not? So the primary goal is, once you have the center and the radius, is to check the endpoints and see if they can converge. It could converge on neither endpoint, it could converge on both endpoints, or it could converge on just one of them. It really depends on the problem. So let's look at number 4a. Find the interval of convergence for n equals 1 to infinity, x to the n over n. Now, I believe this will be easy to show what the radius of convergence is. So let's say the limit as n goes to infinity of x to the n plus 1 over n plus 1 divided by x to the n over n. This will be the limit as n goes to infinity, x to the n plus 1 over n plus 1 times n, x to the n. All of the x's except 1 will cancel out. That's x times n over n plus 1. Of course, this is going to converge as long as absolute value of x is less than 1. So we get absolute value of x is less than 1. It's centered at 0 because there's no x minus 1, so that gives us the interval from -1 to 1. Now, we need to check the endpoints. Let's see what happens when I plug in 1. It becomes 1 to the n over n, which is just the sum from n equals 1 to infinity of 1 over n. This diverges by p-series, or the integral test. So we know 1 isn't included. However, let's plug in -1. We know by the alternating series test, this will converge if the terms are alternating, which they are in sign, and if the terms go to 0. As n gets very big, this does go to 0, so this converges by the alternating series test. So my actual interval of convergence will include -1, but not 1, so that means my interval is -1 included to 1, which is not included. So this is how this kind of problem works. You can create an interval using the radius and using our other skills to test the endpoints. So let's look at 4b. It's find the interval of convergence of -1 to the n times x plus 1 to the n over 2 to the n. Now I'm going to rewrite this like this to save myself some time. Okay, so for the ratio and the root test, we get to ignore the negative because we take the absolute value. So I'm just going to take the nth root of this thing, which will just be x plus 1 over 2. Now I know this needs to be less than 1. So what does that mean? Technically the absolute value of this needs to be less than 1. That means that the absolute value of x plus 1 needs to be less than 2. So if we come over here, x plus 1 is less than 2, or x plus 1 is greater than -2. So x is less than 3, x is greater than -1. Just kidding, x is less than 1 and greater than -3. Can't math. That's okay. So it's x is less than 1 or greater than -3. So again, we have an interval. We need to test the endpoints. So let's put at -3. What happens? We get -1 to the n times -3 plus 1 over 2 to the n. -3 plus 1 is -2 over 2 is -1. So that would be -1 to the n times -1 to the n, which is just the sum from n equals 0 to infinity of 1. Because -1 times -1 is 1, and 1 to the n is 1, so this diverges by the nth term test. We could do the same thing for +1, but +1 will just give us -1 to the n times +1 to the n, and 1, that means also diverges because it oscillates. So that means this interval of convergence is from -3 to 1. And lastly, we can look at for C. This is x to the n over n squared. So what happens here? Same test, ratio test. So we have the limit as n goes to infinity, x to the n plus 1 over n plus 1 squared divided by x to the n over n squared, which becomes the limit as n goes to infinity of x to the n plus 1 for n plus 1 squared times n squared over x to the n. All but one x will cancel, so this will be the limit as n goes to infinity of x times n squared over n plus 1 squared. This is going to go to 1, so we know that x, the absolute value of x, needs to be less than 1. So again, it's from -1 to 1. Let's see what happens though when we plug in. At 1, x to the n just becomes 1. It becomes 1 over n squared, and this is going to converge. Kind of BP series integral test comparison. And at -1, we get -1 to the n over n squared. This will also converge because it's alternating series. It goes to 0, and they're alternating in sign, so this gives us the interval of convergence, -1 to 1, both sides included. So that's the different kinds of things that can happen with the intervals of convergence. And we'll look at the last 2 pages. Page 5 is just reading, so I would read it, and then we'll talk about the problem on page 6.